this lesson, we're going to talk about angles and their relationship to parallel lines and what happens when we have parallel lines and what angles they create. But before we talk about that, we need to make sure that everybody knows what a parallel line is. So I'm going to define it as a parallel line, or parallel lines, are any line, that could be two or more. I'm going to say two or more lines that never intersect. They never cross, which means that they always pretty much follow the same lines with the same distance in between them. And as we're talking about it, I'm going to actually draw two of them. I could draw more, but for today's purpose, we're going to just do two. When we talk about two lines being parallel, we actually use the symbol of an arrow, which tells me that these two lines are parallel. Now, in addition to that, I'm going to change color here, and I'm going to draw a random line in between them. Why am I doing that? Well, firstly, this here isn't just called a line. We call this a transversal because it's crossing two or more lines. This is called a transversal. When I have done that, you may have noticed, especially if you've seen previous lessons, that I have created some angles by doing that. So if I zoom in here, this might look familiar to you, and you might see that I have created 4 angles here. We're going to say 1, 2, 3, and 4, like so. And then I've done the same thing here. I have another 4. So we're going to say 5, 6, 7, and 8. So I have 8 angles here. And if I look at them, I notice a few things. If I look at this piece here, especially from prior knowledge, I know that this angle and this angle are the same because they are vertically opposite, and that this angle and this angle are also the same because they are vertically opposite. What do they have in common to these bottom 4 here? This here looks pretty much the same as this here, and it has to be the same as this one because they are vertically opposite. Same for 6 and 7. I know that they are the same, but they look eerily similar to these ones up here. So we're going to talk about why they are the same and what makes them the same, and the different words that we use to justify why they are the same. So on this next slide here, I already have 2 parallel lines crossed by a transversal. And we're going to talk about first the angles that we consider on the inside. So you'll notice the 2 parallel lines here, but I have angles that are on the inside of them. And I labeled them as 3 and 4, 5 and 6 on the last one. Now, if we talk about what's inside and what is the same on the inside, I'm sure just by looking at it that you could guess that this angle here looks and actually is the same as this angle here, for many reasons, especially because we noticed it on this page here, that there were some that awfully looked the same. These were vertically opposite. These were vertically opposite, but they usually are the same, or they are the same measurement. And so why is that? And just like 3 and 6, we also have here 4, an obtuse, and 5, the other obtuse, looking also the same. So we say that angle 3 equals. And we're also going to say that angle 4 equals angle 5. But when we're asked why, the correct term is that they are alternate interior. Alternate is another word for maybe opposite, across, cross. And interior, you could say inside. And that's exactly where these angles are. They are on the inside, but they are also across from one another. They are across or alternating from one another. So we say that angle 3 is equal to angle 6 and angle 4 is equal to f because they are alternate interior angles. So that's for the inside. But what about the outside? So on the outside of these, I drew for you this one and this one and this one and this one, and I labeled them for you 1, 2, 7, and 8. And which ones here look the same? We have an obtuse angle here and an obtuse angle here. but we also have our acute angle here and acute angle here. So they are all on the outside, but not only that, but they are also, once again, across on the opposite from each other. So they are opposite each other. We call these alternate exterior. Once again, alternate as like opposite, across, and exterior as though the outside. So we say that angle 1 equals angle 8, and angle 2 equals angle 7, and we say because they are alternate exterior angles. So already if you see that they look the same, you're probably right. But what's important is that you can actually justify why, and they are because they are alternate exterior angles. And finally, you may have also noticed that this angle here, not only is it the same as this angle here, but you'll know that it's the same as this angle here. And this we labeled as 1, and this is 5. And just like it, we also have that this angle and this angle are also the same, which I labeled as 3 and 7. And then on the opposite side, we have this angle is the same as this angle, which I labeled as 2 and 6. And this angle here is also the same as this angle here, but they share, like they're on the same side, and this is 4 and this is 8. And just to make things a bit clearer to you, we're just going to look at the ones that are on the same side as the transversal. So we have that on that side, and then we have these ones on this side. Now, they are not, for example, 4 and 8 are not both on the inside or on the outside. One is on the inside and the other one is on the outside. And you'll notice that for 1 and 5, 2 and 7, 3 and 7, 2 and 6, 4 and 8, they're not both on the inside, they're not both on the outside. One is on the inside, one is on the outside. And they are both on the same side as the transversal. We say that angle 1 is equal to angle 5, angle 3 is equal to angle 7, angle 2 is equal to angle 6, and angle 4 is equal to angle 8, not because they're alternate interior, not because they're alternate exterior, but because they are corresponding angles. That's what we say. They are corresponding angles. And these are the rules that you will need to help you with all of the rules and finding all of the degree measures for one type of transversal crossing a parallel line. So just for fun, I'm going to draw for you 2 parallel lines crossed by a transversal, and all I'm going to do is give you one angle measure. Because it's obtuse, I'm going to just give it to you as 110 degrees. And we're also going to, for helping us answer this, we're going to label these with numbers once again, 7 and 8. And just through this one angle measure, I hope that you'll be able to find all of the other ones. You're welcome to pause this video and do it on your own and then see what we come up with together. First, I think the easiest one to find is number 4. And because number 4 is vertically opposite 110, we should know that number 4 is also equal to 110 because they are vertically opposite angles. If we go off on that, you may have noticed that these angles 5 and 8 also look very similar to the 4 and the 110 that I was giving to you. We say that angle 5 is 110 degrees. We could say because 4 and 5 are alternate interior angles. We also could say that it's equal to 110 because these two are corresponding angles on the same side of the transversal. For 8, we know that 8 is also 110. Now we know it because it's vertically opposite 5, but we also know it because it's corresponding to angle 4, and its alternate exterior to the 110 I gave you to begin with. But now here comes the tricky part. How are you going to figure out what 2 is if you are given 110 degrees? At the beginning of this lesson, I did mention that these here create some pretty amazing angles known as straight lines. And so I know that 110 and 2 are called supplementary angles, or that together their sum should be equal to 180 degrees. So because they are supplementary, I'm going to do 180 degrees minus 110 degrees, which is what I'm given, to tell me that what's left over is a 70-degree angle. So now I know that 2 is 70 degrees, and everything falls into place. 3 is also 70 degrees because it's vertically opposite 2. And not only that, but all of the angles in this lovely circle here, 110 plus 70 plus 110 plus 70 should equal to 360 degrees. If we zoom out, we should also know that 6 is 70 degrees because it's corresponding to 2, or because it is an alternate interior angle. Also, 7 is 70 because it's vertically opposite the 6, but also because it is corresponding to 3 and an alternate exterior to number 2. And this covers the lessons on transversals and parallel lines and their angles.